of the data science challenge, we're going to be going over Lambda functions in Python. So Lambda is used to create small anonymous functions using this Lambda keyword, and it can be used wherever function objects are needed. It's any number of arguments for only one expression. So you basically have this Lambda argument which leads to an expression. It can be used inside another function. In Python, normal functions are defined using the def keyword. Anonymous functions are defined using the Lambda keyword. And whenever we require a nameless function for a short period of time, we use Lambda function. So here's an example. A Lambda function that adds 10 to the number passed in as an argument and prints the results. So you have x is Lambda. You have a, b, c, and then you see a semicolon. It's multiplying a and b plus c. So x is the initial Lambda function here. So it'll probably be 5 times 6, which is 30, plus c, which is 38, and that's what we see as the output. So you can see how this interplays. There's also a map and filter function in Python. So the map allows you to process and transform the items of the iterables or collections without using a for loop. In Python, the map function applies the given function to each item of a given iterable construct. So list, tuples, and etc. and returns a map object. So you have map, and then you have the function and the iterable. In Python, the filter function returns an iterator when the items are filtered through a function to test if the item is true or not. So we have our filter, then we have our function, we have the iterable. So there's a list of numbers over here. Then we have a string, and then we have the map list. So there's a list, then we have map, our Lambda function, x and y, and it's defined as x and y, and then you have strings and numbers. So these basically go into the x and y values. Then we have our map list printed out. So you have 1 with s, 2 with t, 3 with x, 4 with y, as you can see in the output down here. There's also map implementation, so you can have days. It's giving 4 days, and it's telling us to basically have a model of the days. So you can have the list map, and notice how there's a string function that's swapping the case. So it's actually turning the first letter, which is uppercase, to lowercase, and the rest into lowercase, and then it's doing it based on the days, which is defined here. And these are the modulated days down here. You can also have a filter function. So you have marks here. It's defining study or score. You return the score less than 33, so it might only be 1 or 2 options. And there's a fail list. So you make a list here, filter, you check the study function, and then you look at the marks that are defined in the list, and you print the fail list. So only one person failed, which they got 23%, and it's less than 33. So magic methods in Python. So in Python, magic methods are the special methods that start and end with the double underscores. Magic methods are not meant to be invoked directly directly by you, but the invocation happens internally from the class once certain action is performed. Use the dir function to see the number of magic methods inherited by a class. The advantage of using Python's magic methods is that they provide a simple way to make objects behave like built-in types. Magic methods can be used to emulate the behavior of built-in types of user-defined objects. Therefore, whenever you find yourself trying to manipulate a user-defined object in a Python class, you can use magic methods. So for example, there's an OS path here. You import a join. Class is for the filter of the objects. You define the initialize function. You have self. File path is this tilde. And then file name is test.txt. So this file was probably added in. Self.file, you open this, then you join this file path with the file name, put them together. RT might be something to do with reading. And then there's another function for deleting the self. So you initialized the function, then you deleted the function. You had a class for it as well. You can close the file eventually. So, and there's also a repre method function. So you have a class of strings, you define the initialize function with the self and a string, self.string equals string, and then you're defining an object and this format for self.string. We don't see any outputs here, but this is how the magic methods work. We also have inheritance and polymorphism in Python. So these are very powerful and important concepts. Using inheritance, you can use or inherit all the data fields and methods available in the parent class. On top of this, you can also add your own methods and data fields. Python allows multiple inheritance, so you can inherit from multiple classes. Inheritance provides a way to write better organized code and reuse the code. Polymorphism allows you to define methods in the child class with the same name as defined in the parent class. So we have a class of vehicles here, initialize function with self, name, and color. So you have self.name, self.color. You also define a function to get color for self, and you define a set color, which is self and color, and then you have the get name function here. You have a class for bike, which has the vehicle in it, and again you have self, name, color, and model. There's a super function here which calls the parent class, which initializes the name and color, and you can also get the details for the self. And you add the get name, the model, and the color together. And then there's an object. You basically, for example, there's a bike with this model name, color, and type. And then it's printing those details and getting the name. As you can see, it's defined in the function. So polymorphisms, you can basically import the pi function for math. We have 3 different classes here: shape, square of shape, and circle of shape. And you're initializing the self in the name. You're defining area. There's a super function to call the parent class for square, and you're also defining the area of the self and the length. You have the super initialized function for the circle, and you also have the pi times the self radius times 2, and then it's defining values. So a is the square root of 6, or sorry, square of 6, and then b is the circle of 10, and you're printing the area of a and b. And those are the outputs that we get here. Error is an exception handling Python. So in Python, an error can be a syntax error of an exception. When the parser detects an incorrect statement, syntax errors occurs. Exception errors are raised when an external event occurs which in some way changes the normal flow of the program. Exception errors occurs whenever syntactically correct Python code results in an error. Python comes with various built-in exceptions, as well as the user can create user-defined exceptions. Garbage collection is the memory management feature and is the process of cleaning shared by computer memory. We have some of Python's built-in exceptions. We have the index error, which is the wrong index of a list. Import error, when an imported module is not found. Key error, when the key of the dictionary is not found. Name error, when the variable is not defined. Memory error, when a program runs out of memory. Type error, when a function operation is applied an incorrect type. Assertion error, when a search statement fails. Attribute error, when an attribute assignment is failed. And we also have the try and except blocks. Basically, these try and accept blocks are a block of code which can raise an exception if placed inside the try clause. They handle the exception written in the accept clause. If there's no exception that occurred, the accept block is skipped and program normal flow continues. Try clause can have any number of except clauses to handle different exceptions, but only one will be executed in the case an exception occurs. We can also raise exceptions using the raise keyword. The try statement in Python can have an optional finally clause which executes regardless of the result of the try, and except holds the list item. So it's basically trying for 1 divided by 0. This is undefined, so it won't work. It'll probably give us an error occurred in exit, which is what we see there. User-defined functions. So in Python, user can create their own error by creating a new exception class. Exceptions need to be derived from the exception class either directly or indirectly. Exception errors are raised when an external event occurs, which in some ways changes the normal flow of the program. User-defined exceptions can be implemented by raising an exception explicitly by using a assert statement or by defining custom classes for user-defined exceptions. The assert statement to implement constraints of the program. When the condition given in assert statement is not met, the program gives assertion error and output. You can raise an existing exception by using the raise keyword and the name of the exception. To create a custom exception class and define an error message, you need to derive the errors from the exception class directly. When creating a module that can raise several distinct errors, a common practice is to create a base class for the exceptions defined by that module and the subclass that's specifically creating for different error conditions. And this is called hierarchical custom exceptions. So we have a class of an error with an exception. It passes it. A too small value error, it also passes it. And we have an example. Number is 100. So while loop is here with true, if you're trying the number, you're putting an integer for the input, so input whatever number. If this num is less than the number, raise this error, otherwise do a break and then use this error since it's too small. So it's just plugging in these values. And then I guess the last 2 things are the garbage collection in Python. So it's memory management feature, process of cleaning shared computer memory, which is currently being put to use by running program. When that program no longer needs the memory, can be used by other programs. It works automatically. Python provides good memory management, prevents the wastage of memory. In Python, forcible garbage collection can be done by calling the collect function of the GC module. And when there's no reference left to the object, it is automatically destroyed by the garbage collector of Python and the del method. So we have define test, there's a list, it's appended. You have garbage collection, creation. When it's in this range, you test it, you collect the garbage, and then eventually there's unreachable objects collected by GC. And you can basically see this down here. Then we have the Python debugger. Debugging is the process of locating and resolving the errors in the program. In Python, PDB, which is a part of Python standard library, is used to debug the code. It internally makes use of these 2 modules and supports setting breakpoints and single stepping at the source, and then it sets those breakpoints. So there's a multiplication here, and there's PDB set trace, and you're initializing input numbers and having multiplication. Thanks for listening.